Hi, my name is Nikhil Handigol. I'm a co-founder of Forward Networks. And in this section of the presentation, we're going to look at a new feature called in-app NQE checks. So the focus is going to be on this capability called Network Query Engine that we launched in January at TechField Day Extra in Barcelona. And this is the next chapter in the NQE journey. It's called in-app NQE checks, which is a new feature that we're launching today. A brief agenda. So I'll give you a very brief background on NQE, what it is, what motivated it. And then, but the most of the focus is going to be on this new feature, in-app NQE checks. And of course, there'll be a demo. OK, so here's the backstory. Right? One of our customers, a large service provider, came to us with a pretty interesting problem. Right? In their network, they have basically two different networks. Let's call them an upstream network and a downstream network. So these belong to the same organization, but are managed by different groups in that organization. And the focus of the problem is on a pair of BGP routers. Let's call it upstream router U and downstream router D, belonging to the upstream network and the downstream network, respectively. U advertises BGP routes, and D advertises BGP routes. And U's job is to send it propagated through the rest of its network and to the internet. This is plain, simple, vanilla BGP, right? So what could possibly go wrong in this network? Well, it turns out that quite a few things can actually go wrong in this network. The upstream router may have BGP policies in place that filters out advertisements based on community values, based on AS path patterns, or there could be static routes, or there could be routes coming from IGPs and so on. And when D starts advertising these BGP routes that matches any of these patterns that is being filtered out, then bad things will happen, right? And in this network, things can actually get worse, because they actually have two pairs of these BGP routers, an active pair and a backup pair. And the backup pair doesn't really carry any traffic. And if the problem is in this backup pair, then it will surface only in a failover event. And this being an ISP, there are SLAs in place. And when these things happen, this can be really, really expensive for them, right? So that's the problem. Well, the solution is really straightforward. So the solution, fortunately, is to just proactively check for these issues and make sure that whenever these issues occur, they are handled immediately, right? The solution here is you would look at the advertised BGP routes, and you would look at the installed IPv4 routes in the FIB of the upstream router, compare them, and make sure that every advertised route is actually installed in the upstream router, and good to go, right? So in theory, really, really simple, really easy to implement as a check, as a piece of software. In practice, this can be really hard. The reason is this design pattern is repeated several times across this ISP's network on devices coming from different vendors with different operating systems and different OS versions. So there's a lot of heterogeneity and a large scale to deal with. And modern APIs that give access to the structured data like netconf is not really widely available across all the devices that they have. So the only practical workable solution is to write a program that will SSH into these devices, grab text output, parse this poorly documented unstructured data, and normalize this into a data set, so on and so forth. And ultimately, this never happens for them. And the core of the problem is collecting, parsing, and normalizing this unstructured data, and keeping all this logic up to date as the network evolves is really hard. Here's another example. This is another customer of ours, which is a large payment service provider, came to us with a different kind of problem. So every year, they perform an audit of the network to make sure that the network is ready for the holiday season. And these audit checks span a whole bunch of different kinds of checks that they perform on LLDP status, configuration consistency between HA pairs, OS image version compliance, device naming standards, so on and so forth. And they would like to transition to a state where instead of performing these checks once a year, they do this every single day. But they would like to automate this problem, but they hit the same problem. Collecting, parsing, normalizing all this data, and keeping it all up to date as the network changes is hard. And these are just not isolated examples. Several of our customers have come to us with very similar sounding problems. And so one of them said that it would take a person about 6 months to develop software and to deal with this kind of a problem. And 80% of the effort is just collecting and parsing this information. And this is what motivated us to build Network Query Engine, or NQE. So very quickly, NQE provides access to structured, normalized data about the network so that the users can focus on the higher level aspects of their use cases. the things that really matter for them. And we launched NQE in January. And NQE basically exposes the structured normalized data via a GraphQL-based API to the users. And for the data schema itself, we chose to base it on the OpenConfig Yang models because the OpenConfig community had done all the hard work in defining these vendor-agnostic models, and we didn't really have to reinvent the wheel here. So that was NQE in short. NQE has been in production for 9+ months now, and we've added a lot of new data since launch. And customers are using this NQE for a whole bunch of things. Most importantly, they have been writing a lot of software to perform this custom verification, to perform checks that are very specific to their organization. And obviously, this whole entire presentation is about lessons learned from deployment. So what can we do even better? How can we provide even more value, even faster to our customers? One of the biggest observations is some of our customers came to us and said, NQE is very helpful, very great, but they needed help with the remaining 20% of the journey. More specifically, they wanted to be able to define these checks within the application, not outside the application, but have it live inside the application with a seamless experience around how these checks are triggered with every new snapshot. And whenever these checks failed, they wanted a seamless experience in diagnosing these problems. And some of them even said that writing code in Python or any full-fledged language for that matter is hard because my network engineers are not really software developers. And upon having more conversations, turned out that there were 4 main categories of checks that our customers were interested in creating. That presence of a configuration, for example, is BPDU guard enabled on STP ports, comparing one config or state value to an expected value. For example, every loopback interface in my network should have a /32 IP address. Comparing one config or state value against another value. For example, comparing the admin status and the operational status of my network interfaces should match. Or consistency between 2 or more related elements. For example, route table consistency between VPC peers, VLAN consistency between connected interfaces, and so on. So this is what led us to build this new feature. This is the next chapter in the NQE journey. We call it in-app NQE checks, or NQE checks for short. So at a high level, NQE checks provide the ability to perform custom verification within the forward platform on top of the same NQE data. Again, more concretely, NQE exposes normalized structured data about the network. And with NQE, users could write these custom verifications outside the application. With in-app NQE checks, they can create these checks within the system. All right? So we'll take a look at a demo of this product immediately. Cool. So let me give you a very brief preview of what we're going to do in the demo. We're going to create a very simple custom check. So the simple check that we're going to create is for every interface in my network, if it is admin up, it should also be operationally up. We're going to follow a 3-step process to create this check. Step 1, we will explore the data model that's provided by NQE and find the relevant fields that are relevant for the check that I'm trying to create. Step 2, we are actually going to create a check. And this is important. The way we are going to create this check is by querying for violations, things that are wrong in my network that are against my intent. And for this, we will use 3 simple constructs. For each, where and select. For each, basically iterates over all the data, collections of data like devices, interfaces, and so on. Where restricts the data to what I'm interested in, basically finding violations. And select basically returns the output. We'll see all of this in the demo. And finally, we're going to execute and save this check. And if this query is able to find violations, then the check fails. And the violations themselves form the failure diagnosis. If we are unable to find any violations, then the check passes. That's going to be the overview, the flow of the demo. Okay, let's jump straight into the demo. All right, so this is the demo network that we have seen before. And we are going to now navigate to the Verify tab, Verify application. And there is a new kind of check that is available now. It's called Network Query Check or NQE check. And I'm going to click this link to add a new network query check. So just to remind everyone, the check that we are going to create is around interface statuses. And the intent is, if for every interface in my network, if it's admin up, it should also be operationally up. And if that's not the case, then I want a failure report. Let's give this check a name. Let's call it interface status. And admin up should imply oper up. This is my intent. OK, so step 1. right? So step one is to find the relevant pieces of data. On the right side here, you can see a data model. This is the data that is exposed by NQE. This data is hierarchically organized. There is network at the root. Under network, there are devices. Under devices, there is name, platform, interfaces, and so on. Now, I'm interested in creating a check around the admin status of the network. So let me start by looking for that field. I'll start searching for admin, and I come across this field called admin status. There is inline documentation. It can take two values, down or up. And now I'm going to click this link to see an example of the starter query that gets me bootstrapped with this. All right, so let me copy paste this and get started. So as I mentioned, we are going to use three constructs: for each, where, and select. Now, so if this particular syntax is inspired by Microsoft LINQ, which stands for Language Integrated Query. If you're familiar with SQL, this is very similar to select from where syntax. So it's querying, basically, not programming. Right? So what's happening here? For each, so we are iterating over.
Uh-oh.
Jiggle it.
Jiggle.
Jiggle.
Shame on you.
Keep jiggling.
Jiggle again.
Push down.
Yeah,
Yep, there
we're
we
back.
go.
Perfect.
Nope.
Oh,
Yeah, we're back.
Turn it off and on.
So we are iterating over all the devices, and for each interface, we are iterating over all the interfaces of each device. And select is basically outputting a few things: device name, interface name, and admin status. So this is not doing anything fancy. This is just giving me a way to iterate over all the elements and return the admin status. But the query that I'm doing here is for violations, where admin status is up, but operational status is not up. And so I'm going to add a where clause here. Let me add a where interface dot admin status equals admin status dot up and interface dot upper status equals upper status is not equal to upper status dot up. This is what determines my violation. Okay, so I'm outputting the admin status. I would also like to output the operational status. So let me add that. I see that I made some probably mistake. I see a red underline, so there's something wrong probably.
Spelled it wrong.
I've spelled it wrong. Did I mean interface? Yeah, that's what I meant. Let me prettify this. And execute.
Is it white space specific?
It's not. It's
Okay.
white
So
space
you could just-
agnostic. Yeah, exactly.
Okay.
Yeah. And I immediately get a bunch of results of interfaces that are admin up, but operationally not up. Cool. I've found violations. I can save this check, and I see that the check has failed because it was able to find violations. Okay. So there are other things that are available in this feature. There is inline documentation. There are a whole bunch of examples that some of our users like to use to start from. All of this is built in.
Like duplex mismatch, can we hunt those now?
Absolutely. Absolutely.
Well, so that sounds great, right? But how? I mean, I'm not going to ask you to like code this on the fly, but correlating data between multiple devices, like do I have a duplex mismatch between two devices,
Yeah.
or like can I do a cabling check? For example, we heard in another presentation, I could give a CSV file of this is what my expected cabling should be, and you use this NQE to say, if I provided you what my expected cabling map is, could you use this database and this mechanism to validate that the cabling was actually correct using LLDP?
Great question. Great question. So the model has the topology that's been discovered that's actually present. So the NQE model, I can walk you through the data model, but for every interface, I see what the connected interface is in the actual network. And obviously, this system does not support giving CSV as input, but you can actually convert it into an input of a list that is actually accepted by this.
Okay, so we can feed in input.
You can feed in input and you can run the check.
Yeah, I'll definitely want to follow up.
Yeah, absolutely. Let's do that. Okay, so I just want to wrap up this demo with the original example I mentioned, this BGP advertisements going out and being filtered out. And I'm not going to build this live in this, but this is slightly more involved than the previous simple example that I showed, but it's 30 lines. That's what matters, right? And in fact, most of this can actually be bootstrapped with the examples that are already provided. And actually constructing this check is adding 5 where clauses. That's what it really boils down to.
So when I talk about cookbooks, this is where that matters, right? Like, I mean,
Absolutely.
gobs of cookbook stuff here.
Absolutely.
Yeah.
Can you export your results? You could send them on to someone else.
In the works, it's coming out tomorrow.
Can you get the results via the API?
It is available today.
Okay, yeah. Yeah, okay.
Something important that I would like to stress is this is run across several vendors. It doesn't just work on a single vendor, just on a single platform. This is across all the vendors we support. That's what we believe is the competitive advantage that we have, right? The differentiator. The check that he was running was across Juniper, across Cisco devices.
It's the demo network that you saw across Arista, Juniper, Cisco,
If we
all the vendors.
supported, we have it.
It's there, yeah.
So.
Great.
Yeah, I'm just curious. Was that like an MPLS L3 VPN PE network that you guys were checking consistency against?
It has MPLS in that demo network.
Okay. Was it the PE routers you were checking consistency on?
I don't, so the interface status.
Yeah, I was the operational use case you're
Yeah.
using is really common on PE routers.
This is across
That's why I was-
every single
why I was
device in the
curious.
network, across every single device in the network, including
Okay.
P devices.
But you could limit it.
Yeah, you could restrict it to what you want.
Gotcha.
Okay, so wrap this up really quickly. So this is a new feature that we're launching today with NQE checks. What we've tried to accomplish is an end-to-end experience in a single environment. This is what our users asked for. From development to debugging to diagnosis and reporting to data modeling, data model exploration to documentation, everything in one place. Number 2, we're querying, not programming. This is really important for our users who don't have a lot of programming experience. And this has simple, compact syntax. And finally, guidance and help everywhere, from example query to bootstrap, syntax highlighting, auto-suggesting, actionable error reporting, everything that you saw in the demo. But ultimately, our goal is to reduce time to value from what it would take, 6 months, several months previously, down to just an afternoon. So in summary, in-app NQE checks, it's a new feature that we are launching today. And of course, we'll continue to learn and iterate. And we are super excited about it. We want to see what our customers do with it.
You should be.
Go
I
ahead.
mean, this is next level stuff. I mean, this is really, like, I am that developer who writes for 8 months to do the thing, and now maybe I don't have to. That would be great. So we're spending my time tomorrow.
Fantastic.
Like
So
writing chatbots.
we would love to learn what kind of checks that you would like to create for your network. And of course, what kind of data you would like to see in QA.
MPLS pseudowires, you got that on the radar?
Yeah.
MPLS pseudowire checking consistency state for endpoints as well as pseudowire
Let's talk
transport in the
about
middle.
let's talk about it offline. Yeah.
Okay, cool.
All right. So,
Take a lit.
so Natale Ruello, our director of product management, is now going to wrap up with some closing thoughts on our journey so far.
Thank you.
Can you hear me? Yes. All right. Okay. My name is Natale Ruello. I'm the director of product here at Forward. So what we saw Brandon introducing the company, introducing the platform to those of you that didn't know what we were doing. And then we saw some demos that showcase some of the functionality that is making this product very successful. We saw the path analysis integration with Shiva. We saw how Forward can help in automation with Ansible, with Fabrizio, and then we launched here with you guys the latest addition to our platform, which is the ability to really create custom verification in the app without worrying about collecting and parsing this information, but really focusing on what brings value to the network operator. Okay, now what I plan to do in the next 10 minutes is really wrap it up with just a few considerations on our journey. 2 minutes? Oh, wow, okay. All right, we launched 3 years ago, and now after 75,000 circa model devices, whenever we acquire a new customer, whenever we approach a new deployment, the feeling that you see in the company is a feeling of deep empathy for the network operator. We feel the pain. We saw in Brandon's presentation at the beginning an example of complexity. This is really what we saw in a network that we modeled early this year, right? This level of complexity and that heterogeneity is daunting when you need to operate the network. So we feel the urgency to provide value to this team and to make them more efficient. So, and it's great to stand in front of you on behalf of the team and showcase all this great feature, because we now have the confidence that this platform really can deliver on the promise. We are deployed in these very challenging environments today in production, okay? So there is a motto here that we use when we try to build new functionality. It's Avia Pervia, which is Latin for let's make easy things that are really hard. And you saw some example. This is what we try to do in the product management team as well as in the UX team. You saw a very serious focus on API integration. Two of our biggest customers, respectively with 5,000 and almost 15,000 devices, use our platform mainly through API. So we need to make sure that the API is stable, well documented, and it performs. Those APIs are capable to responding to hundreds of queries per second. So these customers, important customers for us, as you can imagine, rely on those APIs for their network operation. We spend a lot of focus on performance at scale. I see a lot of demo, some are bigger vendors or some of our competitors that are done on a dozen devices. And then I read some specification where they see, they have a scalability up to a few hundred nodes. We are deployed on thousands of devices as we speak in production. And it's really important to understand that performance at scale kills a lot of startups. We have a great engineering team here that was able to actually deliver that level of functionality at this level of scale. We spend a lot of time, as you saw in the UI. We have a UX team that makes sure that all the user experience is great. And you can imagine how hard it is to distill and simplify the amount of network data that we are capable of capturing from the infrastructure, right? So there is a lot of focus to keep things as simple as possible. And these are clearly our key differentiators. And the last thing is technology. We are truly multi-vendor. There is no way you can deliver end-to-end value unless you are a truly multi-vendor, right? And when you support dozens of vendors, you don't need to worry that you need to find a host because it's attached to a leaf that belongs to a specific platform within a specific vendor. You ask for a host, we are going to return that host, whether it's Cisco, whether it's Arista, whether it's Juniper. We discover that host, it's ready for you, okay? So these are the key differentiators I believe we really obsess over, okay? We are obsessing over these 4 points. And at this point, we believe that we have earned the trust of our customers, and we keep earning that trust. We want to make sure that the model remains accurate, remains scalable, and it's always easy to use. And we want to make sure that we become the de facto standard for network verification. This is our goal. As a product manager, this is my goal every time I show up at work every morning, okay?